Hi and welcome to this topic on disks and partitions. This is going to be quite a lengthy module, so we'll have to split it up in multiple parts. And we're going to try to create a full story with lots of examples and things you can try for yourself. Also, we'll make sure that all items that you would need for the exam, if you want to do the exam, are covered as well. Now, the big picture of this topic is that you will be able to manage disks and partition tables, create and mount file systems, and repair and debug. The first thing we'll do is we'll look at the disks in our system. There are multiple ways to do that, but we're going to be using lsblock and fdisk. The first command is really for listing, whereas the fdisk command can also be used to manage the disk and its partitions, next to simply listing the disks. Just to give you a quick example of what I mean, I'm logged in as root. Again, this is not custom, this is not the best practice, but since I have to be doing a lot of stuff being root, I prefer to be root for the moment. By the way, I'm in a testing environment, so who cares? Let me first list the disks using lsblock. Now this shows me a couple of disks to play with. One disk you should not play with is SDA, because that contains your operating system. If you mangle that disk, you will lose your system. In VirtualBox, I created some additional devices of a staggering 1 GB apiece. Size, in this case, doesn't really matter because we're only demonstrating functionality. So I see 4 disks in total, 3 of which are unused. The SR0 device, by the way, is my CD-ROM. I'm not going to go into that right now, but that's a removable device that I could mount and use. The second command is the fdisk command. To list things, I'm going to use the option -L, and also I want to see all the disks, so I grab for SD, so that'll just shows me SDA and the rest. So like with lsblock, we see SDA, SDB, SDC and SDD, with some properties like size and number of sectors, and things like that. And we see that SDA is the only disk that is partitioned. It's got 2 partitions, SDA1 and SDA2. And we don't touch those. Now, before we continue, let's have a look at Henry to give us a small overview of how disks can be partitioned in smaller, manageable parts to work with. So first, there's the disk, say SDB. What we can do is we can create partitions on that disk, on which we can then later create file systems. 1 file system per partition. But when we create partitions, we need to store the information somewhere on that disk. Now this is called a partition table. In Linux we work with 2 formats at the moment. The first one is called MBR, or Master Boot Record, and that's a very old one. The second one is GPT, which is the more modern table. An example of using MBR is that you can create a maximum of 4 partitions. You could create 4 primary partitions or 3 primary partitions and 1 extended partition, which you can then later use to add multiple logical partitions into, which is all very weird. The number of partitions is very, very limited. With GPT, every partition has a globally unique ID, and the number of partitions is limited by the operating system. In Linux, at the moment, this is 128. Another big difference is the maximum size of the partitions. In MBR it is limited to 2 terabytes, whereas GPT, this depends upon the operating system again. Now let's have a look at the fdisk command to create partitions. This can best be explained by demonstrating it. Imagine you want to partition SDB, and then you'd run fdisk/dev/sdb. Fdisk welcomes me and tells me that whatever I change, I will only change it in memory and not on disk. So I will have to write my changes to disk. Now how can I do that? I need help, because I don't know. So I type M. Now most of these options are not very important to us right now. We're interested in the W for writing, and the P for printing, and the N for creating a new partition, and maybe if we want to delete partitions, we can use the D. So if I run P, it gives me information about the size of the disk, the sector size, and some more. But there are no partitions. So let's create our first partition. So we run new. And the first partition we're going to create is a primary partition. So we run p and we can pick a number. Let's just start with 1, which is pretty obvious. Then the first sector is what is the offset from the beginning of the device that we should start with the first petition, which is 2 kilobytes. And we're going to do that. Then we simply enter the size, which is 100 megabytes. And we've created our first petition. We can check that using p. And it tells us we have SDB1, which is our first petition. Let's create a second one. Again, we go for a primary petition, so we run p again. Then we pick the default, which is the second petition. And when we check, we see that the end of the first petition is just in front of the beginning of the second petition, which is all defaulted, which is very nice. So we again say 100 megabytes. And now let's go for the last one, which is the third. We're not going to create a fourth or an extended, so let's just create a third petition, also primary, starting point, which is defaulted. We take that just like we did the previous one, and again we say 100 megabytes. And now when we do a p, it tells us we have 3 petitions. Just by means of an example, let's delete the third one. So we remove the last petition and we print, and we see we have removed it. We're going to recreate it, the third petition, and 100 megabytes, and we're back to 3 petitions. Now don't forget to write this table. If you forget to write it, it will not save it to disk. Okay. So let's check it. We open SDB again, we print the petitions, and we're very happy because we have got 3 petitions on our device with Gdisk. Now let's have a look at Gdisk, which is for GPT petition tables. So we run Gdisk on SDC. So that's another device that we can use. Now we get a load of complaints because it tells us that there's a main petition table, CRC mismatch, so everything is not correct. We can fix this by simply creating a blank GPT. So we go for option number 2. And instead of the M for help, we now have a question mark. But when we look at the options, we see that, well, it looks a lot like Gdisk. So we have the write option, we have the print option, we've got the new petition option, etc. So let's create a new petition. Now we can choose between 1 and 128. Let's go for 1. And then for the offset, so the first sector, let's simply stick with the default. And we choose that, and as with Gdisk, we can say plus 100 megabyte to create a 100 megabyte petition. Now this is new. It says this current type is Linux. Would you like that? You can enter a tag for a petition so as to give applications an idea. This is what you can use. So a swap device, for example, or any other operating system. Sometimes operating systems need to have a particular tag. Now ours will be Linux, so we're going to keep it to Linux, which is 8300. And what we do next is we are about to create our first GPT petition table, and that will override any existing petition table. So let's do that. We enter yes, and we have succeeded. So now we have 2 disks that we kind of modified petition-wise. So when we run the lsblock command again, we see that we have SDB with 3 petitions, and we have SDC with 1 petition. So lsblock recognizes both petition tables. Okay, now when we run fdisk and do a listing again, same story. The only difference is it does not recognize, so it does see SDB 1, 2, and 3, but it does not recognize SDC. It sees that there's a device called SDC, but it doesn't see that particular petition table because that's not an MBR petition table. It is a GPT petition table. So in summary, we had a look at devices, disk devices in Linux, how to list them. We also had a look at how to create partition tables using two commands, fdisk and gdisk. I hope to see you in the next part, in which we will have a look at one more command that has to do with petitions, and then we'll go into creating file systems.